We are told that triangle DEF is similar to triangle JKL, and the order of these letters is really important. If we're going to find the length of FD, I find it helpful to put a variable in place of FD and then find out what FD matches up with over here. Since F and D are the first and last letters of this triangle, they must match up with the first and last letters of this triangle. So FD matches up with JL, which is this segment over here. These two segments correspond to each other. And so I can write the ratio of these two segments, x over 325. Now I know that when the triangles are similar, all the ratios of corresponding sides are all equal to each other. Whatever this ratio is, whatever x is, that ratio better be equal to the other ratios of the matching sides here. So I need another pair of corresponding sides. Well, the only side I know anything about in this triangle is 484. That comes from EF. EF is the last two letters of this triangle name. That must match up with KL. And so EF matches up here. Here's KL over here. EF matches up with KL. So now I can write another ratio, 484 over 300. Those two ratios have to be equal to each other because the triangles are similar. Well, this is a fairly easy equation to solve. Multiply both sides by 325. Cancel out the division by 325. Pick up the calculator to find out that x is exactly 524.3. Repeating, that's the question we were asked, the length of that side. So we have our answer. Moving on to the next problem. This problem doesn't tell us how the triangle names match up. It doesn't even tell us that the triangles are similar to each other. But if we can find a couple of pair of congruent angles, then we'd know how everything matches up. Well, here's a pair of congruent angles. They're vertical angles. And since these lines are marked parallel, I know that this angle has to be congruent to that one. They're alternate interiors. So now I know by the angle marks how things match up. Now I can write a name for this triangle, PQV, and it doesn't matter how I name this triangle. What matters is that I match up the next triangle according to how I named this one. So I need an angle from this triangle which matches up with the letter P from this one. Well, that clearly has to be Z. Those angles are marked the same. And now Q from this triangle. That's an unmarked angle. That could only match up with W from this triangle. And then finally the V matches up with the V. So now I know how things line up, how they match up. If I'm looking for X, that comes from WZ, which is over here. So that matches up with the PQ. So X matches up with the PQ. And then I need another side from this triangle, and that's the only one available to us. We don't know anything about this one here. What does that match up with? Does it match up with the 60 or the 92? Half the time you will be wrong if you're just looking at the picture. What you really want to look at is the names. 75 comes from VZ. That's here. That matches up with VP, which is, oh, not that. That's VQ. VP, it matches up there. So now X over 86 equals 75 over 92. Multiply both sides by 86. Reach for the calculator, find out that X is approximately 70.1. Quick word before I go on to the other ones here. Notice I started both of my equations in this problem here and in this problem here. I put my X in the numerator. You don't have to, okay? But I prefer to because that's going to result in less algebra for me when it comes time to solve the equation. We could have set up this equation here with 86 over the X. That would have been fine, but then this fraction also would have had to be the other way around, 92 over 75. You're going to get the same value for X, so I don't care which way you set up the equation, but it has to be set up correctly. And I don't know how you're going to set it up correctly if you can't match up the letters correctly. That's why target 1 from last week is so important. We're doing target 2, but if you can't match up the letters properly, you're not going to get very far on these problems here. Number 3. I've got parallel lines, so I have congruent angles here and there. Those are corresponding angles. And I have congruent angles here and there. Those are corresponding angles. Also, this angle is congruent to itself. I'll put 3 marks in that to distinguish it from the other 2. So now I know how all the angles match up. So I can name the little triangle up top, let's call it JVK. What would that be similar to? Well, J from the little triangle matches up with J from the big triangle. It's the same angle. Okay. And then from J I go to V. So in the big triangle I've got to go to T. T and V match up. And then finally A matches up with the K. Now I know how things match up with each other. And so I can match up my X. What does X match up with? X is from JV. So JV matches up with JT. So X, JT, JT, JT is this whole thing. How long is that whole thing? It's not 3. It's X plus 3. See, if you don't write these names here and you don't pay attention to what JV matches up to, I'm afraid you're going to write X over 3, and that would be trouble. You're going to get the wrong value for X if you start this equation this way. JV matches up with JT, and JT is this whole thing. It's X plus 3. It would have been nice if the variable only showed up in one place in this equation. That would have made life easier, but it doesn't, and there's no way around that. So now I need another side from the little triangle here to start my next fraction. Well, the only side I have to choose from is the 16. Hopefully that matches up with the 20. That would make life easy. Let's find out. VK, there's my VK. That matches up with TA, and TA is 20. Okay. Now this equation is going to take a little bit more work. We've got to cross multiply. 20 times the x equals 16 times the entire x plus 3. Make sure you put parentheses around that, or you might forget to distribute. So 20x is equal to 16x. 16 times 3 is 48. Subtract 16x from both sides. 4x is equal to 48. And then dividing by 4, finally x is equal to 12. If you don't set up the equation right, you got no chance of finding the correct value of x. And I don't know how you get the equation set up right if you don't name the triangles properly. Okay, we're writing down triangle names for a purpose, and that's so that we set up the equation correctly. Let's move on to number 4. I got parallel lines again, so I've got congruent angles there because they're corresponding angles. I've got congruent angles here, they're corresponding angles. They look like right angles, but I don't know that. In any case, they're congruent to each other, and that's all I need. So let's write some triangle names. The big triangle is SCL. What is that similar to? Well, SCL, that's a single arc, a double arc, and an empty angle. Here in this little triangle I got a single and a double and an empty, so that would be MIL. So now I'm going to start setting up ratios. And the x comes from CI. CI doesn't come from this triangle or this triangle. I can't just write x. It's not a side of either one of these triangles. But it is part of this whole side of the big triangle there. I can use CL, and that whole thing would be x plus 33. That's side CL. That matches up with IL. And how long is that? IL is 33. Okay, so I've got a side from this triangle, x plus 33, over the corresponding side from that triangle. Now I need another side from this triangle, either SC or SL. Well, I don't know anything about SL, but I do know that SC is 18, and that matches up with MI, which is 15. I'm not going to cross multiply here. I'm instead going to multiply both sides by 33. Simplify that. 18 over 15 times 33 is 39.6. The calculator can do that for me. Subtract 33 from both sides, and you get x equals 6.6. Again, there's a purpose for writing the triangle names down. There's a purpose for it. We're not just writing them down because I like writing them down. We're writing them down because they tell us how to properly set up the equation. And if you can't set up the equation, you will not get the correct value for x. Moving on to number 5. Okay, I've got one pair of congruent angles already. The only other pair of congruent angles I can be absolutely confident of is this angle B up here, which belongs to the little triangle and to the big triangle. Guaranteed it's congruent to itself. These triangle names are a little tricky now. I'm going to name the little triangle BLR, and that's similar to, so BLR I went double arc, no mark, single arc. So in the big triangle I've got to follow the same progression from a double to an empty to a single. Well, in the big triangle that would go from B to T to Y. There's your double mark, your empty, and your single. So B, T, Y. Okay, now I know how things match up. The X comes from TY, which matches up with LR. So I'm going to put X over LR is 20. Now I need another side from the big triangle, BTY. Let's see, BT, I don't know what BT is. I only know how long BR is. I don't know how long that is. What about the other side? How long is BY? BY, oh, all right, that I can find out. 24 plus 36 is 60, and that matches up, the BY matches up with the BR, and the BR is 30. So I've got 60 over 30. Multiply both sides by 20. X is equal to 40. Okay. Last two problems we're going to do for today. Number 6, a 5-foot girl standing outside casts a 32.6-foot shadow at 6 p.m. on a summer day. So here's the 5-foot girl, and at 6 p.m. the shadows get kind of long, and there's her shadow. It's on the ground. Well, let's assume she's standing straight up. I think that's a fair assumption to make in this problem. At the same time, the high-rise building she's standing next to, so there's some big high-rise building over here, and we know the length of the shadow of that high-rise building. Very long shadow, 875 feet. What we don't know is how tall is the building. So let's put a variable up there. I'm going to call it B for the building height. Okay. Since these shadows are being cast at the same time, in virtually the same place on the earth on a summer day, it's fair to assume that the sun's rays that are creating these shadows are coming down at the same angle. The sun is coming over this girl's head at the same angle that it's coming down over the top of that building. So the triangles are definitely similar to each other. The building height matches up with the girl's height. The building shadow corresponds to the girl's shadow, and we can write B over 5 is equal to 875 over 32.6. Okay, height over height, shadow over shadow. Multiply both sides by 5. Let the calculator do the rest of the work. The building turns out to be approximately 134.2 feet tall. Okay. Finally, number 7. Okay, and we're back to me telling you how the triangles and how the angles and how everything matches up with each other. We don't have to figure that out this time. I'm telling you that information. I want to find the measure of angle C, this angle measure right there. Don't go by the picture. You could get fooled by the picture. Go by the names. Angle C matches up with angle A. And angle A is 62 degrees. So angle C must be 62 degrees. Now if we're looking for angle D also, what's the measure of angle D? What does that match up with? D is in the middle. That matches up with B in the middle. Uh-oh. I don't know. I don't know what B is. How can I know what D is? Well, you won't know unless it occurs to you to put the measure of angle C in the picture. If you do that, now I bet you'll realize that you can find angle B. Subtract these two from 180, minus 65, and minus the 62, and that will get you 53 degrees for angle B. And so if B is 53 degrees, then D also has to be 53 degrees. And that's it for today.